that whenever we have got a fixed support, how many reactions are there for a fixed support or in the cantilever beam? So in a cantilever beam, we have got 3 reactions, that is vertical, horizontal and inclined. So we can show over here that we will have the value of vertical reaction Vc, horizontal reaction Hc and couple moment of Mc. Okay. So now I have to first resolve the force into 2 components, that is vertical component and horizontal component, right? So the force is inclined at an angle of 60 degree with horizontal. So horizontal component will be 10 cos 60 and the vertical component will be 10 sin 60. Okay. Now if we want to find out the support reaction, will apply our conditions of equilibrium, that is sigma V is equal to 0, sigma H is equal to 0 and sigma moment is equal to 0. So we first apply our condition, that is sigma H is equal to 0. So HC is moving towards positive x-axis plus, and 10 cos 60 is also moving towards positive x-axis. So positive, that is equal to 0. So HC, that is equal to minus 5 kilonewtons. Then our second condition of equilibrium, that is sigma V is equal to 0. So sigma V is equal to 0, 10 sin 60 in the vertical upward direction positive and Vc also in the vertical upward direction positive, that is equal to 0. So it will be 8.66 Vc, that will be equal to minus 8.66 kilonewtons. And third is sigma moment is equal to 0. So moment about support C. Moment about support C. First is 10 cos 60. The line of action is coinciding with the point, so it will not produce any moment. Second is 10 sin 60. So 10 sin 60 into what is the distance? 2 plus 2. So that is 4. And it will, according to our right hand thumb rule, the force is upwards and the fingers are moving in which direction? Anti-clockwise. So it will be minus. Then 5 kilonewton in the clockwise positive and MC in the anti-clockwise negative, that is equal to 0. So MC, that is equal to 29.64 kilonewtons. Okay. So MC value, that will be equal to 29.64 kilonewton meters. So we have obtained our reactions, right? Now what is our step? The step is that we have to change the direction of the reaction if the answer obtained is negative, because we are assuming the directions of the reactions, right? Now HC we have got it as negative. That means if HC value is negative, my assumed direction is wrong and I can change the value, the direction of HC and show it in this particular direction. Similarly, VC is negative, so our assumed direction of VC is also wrong and it will act in vertical downward direction. So downward direction VC we will show and write down as 8.66 kilonewtons. And the third is moment MC. So MC obtained is positive, so we don't have to change the sign, 29.64 kilonewton meters. So our second step is over to show the correct direction of the reactions if the value obtained is negative. Now our second step is to calculate the support, the shear force values. So step 2, calculate shear force values. Now to calculate the shear force values, shear force is basically defined as what? Unbalanced vertical force. That means I have to consider only the vertical force. I don't have to consider the horizontal force, right? So to start with, shear force at point A, just right. So just on the right side of A, there is no force acting. It will be equal to 0. Shear force at point A, just left. So on just left, we will draw one line, okay, and put our hand. So on the left side, that is 10 sin 60, and it is trying to push the right portion in the upward direction. So it will be taken as minus. So minus 10 sin 60, that is nothing but 8.66 kilonewtons. Negative. Then shear force at point B. So at point B, it is a couple. So we are calculating force. So we don't have to consider that. Directly its value is minus 8.66 kilonewton. And shear force at point A is a support reaction. So for support reaction, it will be just right and just left. So on this particular right side, only one vertical force, so minus 8.66 kilonewtons, and shear force at point C, just left. So on just left, that is on this particular side, if I put my hand, 8.66 positive and 8.66 negative, so net value will be equal to 0. Now we can take all the points where we have calculated the value of shear force and draw the shear force diagram. So it is baseline, positive values above the baseline, negative values below the baseline. We can see that we have obtained all the values as negative, right? So to start with, shear force at point A, just right 0. Shear force at point A, just left minus 8.66. As it is a vertical load, it will be a vertical line or a point load. So we have to draw a vertical line. Shear force at point B, again 8.66. No load between A and B, it will be horizontal line. Shear force at point C, just right, again minus 8.66. No load between C and B, again it will be a horizontal line. And shear force at point C, just left 0. As reaction is a point load, we have to draw a vertical line. Show the confinement of the area where shear force is acting. Show negative sign as it is below the baseline. Write down the values 8.66, 8.66 and shear force diagram. Very simple, but what students make mistake is they are unable to understand that they have to consider only vertical load or horizontal load or an inclined line. But the definition itself suggests that as it is a unbalanced vertical force, you have to take only vertical component. Is it clear? Okay. Now we go to our third step, that is bending moment calculation. So step 3, bending moment calculation. Now to calculate the value of bending moment, I will just remind you once again that when the couple is acting, we have to calculate the bending moment just at right and just at left. Other things are as usual. So we start with bending moment at point A. Okay. So at point A, you put your hand and see on the right side there is no force acting to produce moment, so 0. Bending moment at point B. B is a couple, so we have to take just right and just left. So at point B, you have to put a section line on the right side, or I should put it over here so that you don't get confused, outside the couple. Okay. Now if I take bending moment on the right side, how much force is there? 10 sin 60. What is the distance? 2. So 10 sin 60 into 2. It is anti-clockwise and it is producing sagging moment, so it will be plus because it will rotate like this. So it will push the beam in the downward direction, so positive. So 8.66 into 2, that is 8 2s are 16. So 17.32. So 17.32 kilonewton meters. Then we come to bending moment at point B, just left. Just left means just left of the couple. Okay? So now how many forces are there? There is one force and one moment. So we start with first is the same value we will write over here, that is 17.32, and the second is a couple. It is moving in which direction? It is moving in clockwise direction, and it will rotate and try to lift the beam in the upward direction. So it will be hogging, so minus 5. So that will be equal to 12.32 kilonewton meters. And bending moment at point C. Now C is also having a couple, right? So I have to calculate just right and just left. So this is just right of the couple. So how many forces are there? One force and one couple. What is the distance up to point C? 10 sin 60 into 2 plus 2, that is 4. So plus 10 sin 60 into 4, and second is couple, that is 5. So 10 sin 60 into 4, 17.32 into 2. So that is 34.64 minus 5. So 34.64 minus 5, that is 29.64. So 29.64 kilonewton meters. And bending moment at point C, just left. So just left on this particular side. Okay, that means I have to include the couple, right? So it will be equal to what? 0. So now we can draw the bending moment diagram. So to draw a bending moment diagram, we will draw a baseline, then bending moment at point A 0, bending moment at point B just right 17. So 10, 20, 30, 40. So 17 will be somewhere over here. What is acting? No load between A and B. It will be a inclined line. Bending moment at point B just left 12.32, somewhere over here. What is acting? Couple. So it will be a vertical line. Then bending moment at point C just right 29.64, approximately 30. What is acting between C and B? No load. It will be a inclined line. And bending moment at point C just left 0. So as it is a couple, it will be a vertical line. Show the confinement of area where bending moment is acting. Show positive as it is above the baseline. Write down the ordinates, and this completes our shear force bending moment diagrams. Okay, we have covered all types of problems, so you will be able to solve any numerical if your basic concept is clear. The basic concept is that what is the type of loading? Depending upon the loading, you have to draw the diagram. If it is a point load, vertical line in shear force. If it is a UDL, inclined line in the shear force, and a curve of second degree in the bending moment. Okay, so I hope that you have understood shear force and bending moment diagrams. Thank you.